Mount Etna is now giving scientists a disturbing new challenge, because what it's recently spewed out has left experts baffled and even alarmed. According to cutting-edge research, the signals deep within the Earth's crust were supposed to help forecast Etna's next move. But this volcano seems determined to rewrite the rulebook. After the latest mysterious eruption, a serious question hangs in the air. Are we witnessing an unprecedented shift in volcanic behavior? And if so, what could that mean for the people living in Etna's shadow? It goes without saying that Mount Etna is one of the most closely monitored volcanoes on the planet. With 500,000 years of geological activity and nearly 3 millennia of human observation, it's built a reputation for constant restlessness. Europe's largest active volcano is under 24/7 scrutiny because roughly 1 million people, around 1/3 of Sicily's population, live on or near its slopes. Over time, volcanologists thought they'd begun to understand its personality. Frequent rumbles, spectacular lava fountains lighting up the Sicilian sky, and then stretches of uneasy calm. Etna has always been active, but its overall behavior was considered familiar, even predictable. But the situation unfolding now shows that even a volcano studied for thousands of years can still hold dangerous surprises. Until recently, scientists were making real progress in forecasting Etna's mood swings. A major paper published this year proposed a groundbreaking method of eruption prediction based on subtle seismic signals inside the crust. Researchers were focusing on something called the B value, essentially the ratio of small earthquakes to large ones happening beneath the mountain. Shifts in this B value are tied to changes in stress within the crust as magma moves upward. When the stresses rise, the pattern of earthquakes changes too. An updated model analyzing data from nearly 2 decades revealed a strong correlation between B-value drops and eruptive activity, often months before other warning signs even appeared. In other words, if the technique holds, scientists may soon have a reliable early warning tool for Etna, potentially granting communities far more time to prepare. But while one research team was cautiously optimistic, another was sounding an entirely different alarm. For years, some believed Etna's southeastern flank, which is slowly sliding toward the sea, was being pushed outward by magma from within. It seemed logical. Pressure from below forces the volcano's sides to bulge outward. But new evidence turned that assumption on its head. A separate study strongly indicated the slide is primarily driven not by magma pressure at all, but by gravity slowly pulling one of the mountain's massive flanks downhill, especially the sections below sea level. That finding raised eyebrows worldwide. A gravitationally driven slide is more unpredictable, more susceptible to sudden shifts, and, in a worst-case scenario, capable of producing catastrophic flank collapses. Events like that, though extremely rare, have happened at other volcanoes across the globe and are known to generate devastating tsunamis. Nobody is suggesting that Etna is on the verge of such a collapse, but the fact that the necessary geological conditions exist has placed scientists on alert. The problem? There's no way to know when or even if such a failure might occur. In other words, even before the latest activity, Etna had given volcanologists plenty to worry about. And then 2025 arrived, and the mountain appeared to confirm their concerns in dramatic fashion. The warning signs started in early February. Instruments recorded a swarm of unusually deep earthquakes beneath the summit, deeper and more frequent than Etna's typical seismic chatter. It was though something inside the volcano's plumbing system had shifted. At the Observatorio Etneo, the institute responsible for monitoring the volcano, scientists noted that the volcano's breathing had changed. A persistent, low-frequency tremor had taken hold, unusual enough to raise immediate concern. It was the kind of signal that suggests magma is rising in a new way or through a new pathway. Those who understand and studied Etna well could feel it. Something didn't sit quite right. The usual patterns weren't holding, and the mountain had gone quiet in the wrong kind of way. But even with that unease, nobody expected what came next. Just before dawn on February 13th, Etna erupted violently. On its southern flank, a new vent burst, releasing lava that raced down the hill for kilometers at a terrifying speed. The landscape was illuminated like fire across stone by the powerful, deep orange brightness. The mountain screamed as enormous ash plumes flew into the sky, prompting flying warnings. But this wasn't just another eruption, it was a paroxysm, or a sudden explosive outburst that sent a pyroclastic flow surging downslope. Luckily, it missed towns, but seeing one on Etna at all sent shockwaves through the scientific community. And then came the biggest shock of all. The lava wasn't the usual basalt. It looked different, hotter, stranger, unfamiliar. A research team risked everything to grab a sample during a brief lull, navigating tremors and ash just to learn what Etna had really unleashed. Whatever it wasn't typical, and it left one thing clear: something deeper had shifted beneath the surface. Scientists successfully secured a fresh piece of the molten material and rushed it to a laboratory in Catania. That's where the mystery deepened. When technicians opened the insulated container, the sample released an intense vapor. It was extraordinarily hot, far hotter than expected for the time elapsed since collection. Sensors detected unusually reactive gases. Lab staff immediately activated emergency protocols when some readings spiked beyond typical volcanic gas profiles. A minor burn incident occurred despite protective equipment, which raised even more questions about the sample's properties. Within minutes, the lab entered a controlled lockdown, placing the volcanic fragment in a sealed negative pressure chamber. Nothing about the sample's behavior aligned perfectly with Etna's usual eruptive products. And while no one is suggesting it represents a fundamentally new material or anything unknown to science, the discrepancy was striking enough to demand deeper investigation. Initial testing could not immediately match it to Etna's typical basaltic signatures, a finding that alone was surprising given the volcano's well-established composition. Meanwhile, remote sensing teams were analyzing Etna's interior using seismic arrays and muon imaging. What they found added a new layer of uncertainty. Areas of the volcano that normally displayed dense rock or magma pathways abruptly became low-density zones, resembling voids or empty pockets. These were interpreted by some experts as regions where magma had quickly drained, while others suggested that the internal structure may have collapsed. While none of these interpretations indicate an impending catastrophe, they all support the fact that Etna is going through changes that volcanologists have never been able to record in real time. The public's response to the eruption was swift as word quickly spread. There was a lot of backlash when it was revealed that two private companies had tried unapproved drone flights close to the eruption site. Etna is a UNESCO World Heritage Site, and Sicilians are fiercely protective of it. Environmental groups organized demonstrations, demanding strict oversight and condemning any attempt to exploit the volcano's activity for commercial gain. Local officials quickly reassured the public that unauthorized access was prohibited and that scientific monitoring, not corporate opportunism, would guide the responses to the ongoing crisis. Stepping back now, Etna's 2025 eruption stands out as one of the most unusual in its recent history. Never before have researchers highlighted such a puzzling combination of seismic anomalies, flank movement concerns, changes in internal density structures, and eruptive material that doesn't neatly align with the volcano's standard geological profile. It's the kind of multi-layered event that will likely fuel extensive scientific study for years. The truth is, we still have far more questions than answers. No one can yet say exactly what triggered the unusual characteristics of this particular eruption. No one can say whether the internal voids represent a temporary shift or a structural vulnerability. And no one can predict with certainty whether the slow movement of the southeastern flank will remain stable or if it'll accelerate in the future. What we do know is this: Etna is changing, and it's changing in ways that challenge long-standing assumptions. For the people living around the volcano, this is a stark reminder that even the most studied mountains can still defy expectations. For scientists, it represents a rare chance to observe potentially significant geological processes unfolding in real time. And for the rest of the world, it's a sobering demonstration of how dynamic, powerful, and unpredictable our planet can be. So, where does Etna go from here? Will it settle back down into its usual rhythm of eruptions, or is this eruption a precursor to a longer period of instability? Right now, all eyes are on the mountain, from local villagers watching the summit glow at night, to researchers analyzing seismic data, to policymakers considering new safety measures. One thing is certain: Mount Etna has stunned the scientific community, and its story is far from over. If anything, we may be witnessing the opening chapter of a new and complex phase in the volcano's long life. And as always with Etna, the next development could arrive without warning. What do you think is driving Etna's strange behavior? And could this be a sign of something bigger on the horizon? Let us know in the comments down below.